Hello friends, in this lab exercise we are going to learn how to add an extra or a spare disk to our existing virtual machine. We'll also see how to format it or how to use it as an independent disk partition or as part of our logical volume manager. Existing logical volumes we can extend them using that spare disk, or we can use it as a separate mount point to access it. Now, let's see uh, practically. First is we have this disk STA of size 21.5 GB, which has two partitions, STA1 and STA2. This is the command we have to execute. If I don't specify this, the STA, then it will list all the volumes, all the partition and all the disks. Currently, this session is inactive because I have powered off this machine. So I go here, this is the machine, and go to settings. I'm using VirtualBox Manager from Oracle. Go to storage. I have this disk which I'm going to remove for this exercise. Again, I click settings, storage, click here. It will add a new hard disk. We'll create a new hard disk, or we can use an existing one. So I'm going to create one hard disk. Size for this hard disk is let's say uh, 5 GB. I want to give a new name to this disk, my disk or spare disk, whatever name you want for the disk file. Select my disk. It is listed here now. Okay, let's start our virtual machine and see how things go. While the machine boots up, let me tell you something. It's been running today for some time and it's really feeling good now. Okay, I can hear the chirping of the birds. That sounds good. And reflections. Awesome. Now, uh, let's see. So when your Linux machine boots up, you can hit, for example, function key F2 to see what's going on behind the scene. So you can actually see the logs, the boot logs. It's going pretty much fast. Very good. Okay, that thing proxy thing failed, no problem. To perform this active, we have to be the root user. So I'm logged in as the root user. My IP, it has not changed, I think, so I can just restart this session. Yeah. Now let's f disk again -l slash dev sdb, because SDA is our first disk. We have the SDB of about 5 GB size. Good, we got it. I can minimize the console thing. So out of this 5 GB, we can use it to enhance the size of an existing logical volume. We have these logical volumes as part of LVM, or we can use one whole disk as an independent partition also. It's up to us. So what I'm thinking is I will create two disks. One we will use as an independent partition. Another disk we will add to our volume group under LVM. What is volume group? Use VGS. CentOS is the volume group, which has about 1 GB of free space. So we'll increase it, and then we can use the extra space to extend any of these existing volumes if we need, or we can create one separate partition, sorry, mount point to mount that new volume. So let's do this. Fdisk /dev sdb. You can use M to get some help. What options are available? A to X. I'm going to hit N for new. So 0 primary, 0 extended, 4 are free. So there are 4 primary partitions available. And this is a new disk. So there is no partition as of now. It is up to you. You use primary or extended. Okay. If you have already used all the primary partitions, then of course you can use extended partition. So let's use primary for this exercise, and that is the default as you can see. So you can just hit enter or type P here. Now 1 is the default because that would be your first partition number. So SDB1, SDB2, like that. I hit 1 here, but no need. So let's don't type anything this time. Okay, so 1 is chosen. Now first sector is your 2048. Okay, before that whatever is used being used is for the metadata, I think, or super block we can call. Now from 2048 it will start. So I'll go with the default. Now what is the size we want for this partition? So I can say, if I don't say anything, I hit enter, then entire disk will be used. So let's say 1 GB or maybe 2 GB, because we have 5 GB large disk, so 2 GB. Okay, partition 1 of the type Linux and of size 2 GB is set. Okay, W for saving the changes or writing the changes. If you want, we can create more partition right away, so let's do that. N for new. Now you see one primary partition is available and 3 are free. So I'm going to use primary again. Default is 2. Yes, the second partition. Start from whatever sector it is available and up to 2 GB only. Now I hit W. I leave that 1 GB there. Okay, let's do one more thing. Let's create one more partition. This time default, default, and whatever is left, use it. Okay, so that is about 1 GB W. Okay, so we have seen different approaches. Syncing disk done. So let's use F disk -L /dev sdb. So we can see that out of the 5 GB of total disk space, we have created these 3 partitions. Okay, let me show you something. /dev /sda and sdb. So SDA was our original disk, which has the OS, which has the data, everything. You see star here. So SDA1, that is an independent partition which has the boot media or the kernel and the initial RAM disk, etc. So we can say the OS thing is here. SDA2 we are using as LVM for /home /tmp. Okay, volumes for those mount points. Now this STB we just add it as a spare disk and we have created 3 partitions out of it. Okay, now the thing is, if you are going for an interview, okay, or maybe preparing for an interview, notice that Linux partition ID, that hex value is called 83. But when you use Linux LVM, you can change the label and set it to 8E, not 83. Okay, so this is Linux LVM. The hex value is 8E. Partition ID you can call it, for example, or label. Remember the word labeling. Okay, so you can use the fdisk command again to set a label. Now let's use this disk SDB1, and we will not add it to our existing LVM environment. So what we do, we can right away format it. So mkfs make file system, you hit dot and you see several options are available, ext2 3 4. Okay, or you can also say mkfs-t and then you specify the file system type. Okay, that will be used for formatting. So xfs for example, because this is the latest one. Now the partition or the disk. So this is the disk. We are going to format. Formatting is pretty much fast. So metadata, for metadata about this much space is there, and other statistics you can verify here. Now this has got the file system layer on the top of the actual partition, so we can use it now. To use it, all we need to do is mount it. So mount this disk onto this directory /mnt. This is a mount point available usually for testing purpose or for temporary mount, so you can mount it there. But before I do that, let me run this command df-h/mnt to see if there is already something mounted upon it. Nothing. You see mounted on root, so that means it is just a directory which is part of the root file system. It is not a separate partition in itself. One more thing, ls-l/mnt. There is nothing in there. Okay, now let's come to our command again. Hit enter. Now let's run the same command again, so you can see the differences. That time we had it mounted on the root file system itself, so that means it was not a separate mount. Now you see /mnt, so this disk stb1 is on /mnt. You see the difference? Earlier we had the root file system here, so mnt was not a separate mount or partition. So stb1 is mounted here. Now you do this thing /mnt. There is nothing because we have not created any directory. So let's go into this directory and verify. So we can do something echo hi there greater than and a file name. Let's say file. We have created the file. We can view the contents of that file. Now I hit cd to go back to my home directory, and I use df command also again with the -h, so it will list all the partitions or volumes. /mnt is also there. Once tested, you can use it for some other mount point, such as let's say we create mkdir. I want to create for my team for sharing some common data, maybe code, scripts, programs. Now we unmount it from /mnt. Done. If I hit /mnt, it is blank because the files are still there, but on the disk, which is not mounted yet. Now mount it /dev stb1 slash team ls-l slash team. You see the file is there. So when you unmount, your data is not lost. Use df-h. You don't see /mnt now, you see /team. You see the total size is 2 GB. Now this is a successful activity. If you reboot your system, this mount will not be available. It is a temporary mount because we executed this command. So what we do, we can make it a permanent mount. Whenever we reboot, it will be there. How we do that? So let's have a look at this file /etc fstem. It has entries for permanent mounts, as you can see examples there. What we need to do is we need to just make one entry for the new volume. So let's do that. As a good practice, always make a copy. As a best practice, I would say make a copy of your original configuration file in case you mess up with your configuration file. Now use VI to edit it. Go to the end of the file, hit Shift Z, hit O. It will enter a new line and you will be in the insert mode also. Slash dev sdb1. So where do we mount it? Under slash team. Okay, you want to keep this formatting, you can keep it. Spaces are extra spaces are ignored. You can say that this is XFS. Use the default mount options, and I don't want the file system check, so I'll just disable it. WQ7 exit. Let's verify the contents. Okay, there is another way, good way. You verify like this. Okay, so you can see that this line is extra in the first file, so we can compare the contents of the two files. Okay. Good. Now I do this df-h, we already have it mounted, so let's unmount it. Again df-h, it is not present. Okay, as you can see, you can use this command, it is not there. Okay, now use mount command with -a, so it will read your all the mount related entries found in this .data.fstf file under /etc directory. No error means good. Zero exit status means the last command was successful. df-h, it is there now. So whenever your system reboots, this mount point will be available. If you are using an application or service that accesses a particular mount point, ensure that it is available across reboots. And now you know how you can do that. Now, uh, this is a complete exercise. Okay, let's come to this point again. fdisk-l/dev sdb. So we have this sdb2, sdb3. What we want to do with them? Let's use this sdb2 uh, for our LVM system. Okay, because our volume group, it is the name is centos. It has only 1 GB free space. Total size is 16 GB, and we have some logical volumes such as home, root, etc. And we want to increase the size of those volumes. For example, I want to increase the size of this where logical volume, because I want to add server data, FTP data, my website data. So I want it to be sufficiently large to hold my server data. So I can increase the size of this. If I am having more users, I can increase the size of this volume also. So, or maybe I want more swap memory, I can do that also. So let's first add this STB2 to our volume group. How we do that? Now, from this point, we are going to learn about LVM. Okay, so far whatever we have discussed is applicable to standard partitions. Now let's do this. PV create. So the first step is we create a physical volume. See, we did not format this, okay? STB2 thing because we are not directly mounting it. So we are not formatting it. It is successfully created. Now use PVS, PV scan. So STB2 is also present, but we have not added it to our volume group yet. And the size is 2 GB. So volume group is, as you can see, centos, and only one physical volume is present. 1, 2, 3, 4, 5. Total 5 logical volumes are already present or created. So VG extend. We can use VG create if there is no volume group already there, or we can create a new volume group also. Understand? So extend this volume group and use this physical volume. Done. Clear the screen. VGS. Now there are two physical volumes here. Use PVS also. As you can see, now it is part of CentOS volume group. Now VGS tells you that about 3 GB of disk space is free. Not disk space, we can say uh, roughly disk space, that this much space is free which we can use to extend existing logical volumes as part of LVM environment. Now what we do, we have LVs. So what LV you want to extend, you can use that LV, or you can create a new LV also. So let's do one thing. Let's create a new LV. So how we create? Use LV create. What is the name of the LV you want? So let's say that I want under this mm, the device, my existing group is CentOS. Under that I want to create scripts. I have all my codes or scripts here. So now the size hyphen L, capital L. Okay, you can specify small l also for you can I'll show you what it does. Small l is for extents, and capital L you can use to say something like this, that 512 MB or maybe 1 GB, like that. So I would say 512 MB. That's it. XFS signature detected. Wipe it. Yeah, you can wipe it. No problem. What happens? Sorry. Did anything wrong? No, SDB2 we did not use it. So why it is saying if I hit, why it will keep asking me? LVS scripts. So the way we create, we can also remove it. In the same way, use the lv remove command. Now, this problem which we just noticed, I'm just wondering why it happened. We did not create XFS on it. We created only on the SDP1, not on SDP2. Okay. Again VGS, we have the space there. LVS, we don't have any new logical volume. We created but we removed it. Again LV create, so hyphen n, let's say scripts again, and it has to be part of our centos group. Hyphen L, capital L, that size is, let's say, 1 GB large. Create it. Okay, this went fine. So instead of that syntax using this method, I thought we could use this just fine. So yeah, let's not use that method. Okay, scripts created. Now LVS, we have scripts here of 1 GB size. Now the logical volume is present, but we have not formatted it. So now we are going to format it. So mkfs dot, you can use any one of them. Let's use xfs, and slash dev centos. You see, we have scripts here. Done. Earlier we used hyphen t then xfs with the mkfs only, but these variants are also available, so we can use them directly. Now lvs and vgs, free space is 2 GB only. Use pvs, and you can see hdb2 is part of centos, and size is reduced as well. Now mkdir, because we need a mount point to access that volume, slash scripts. There is nothing in there, and it is not a separate mount as of now, or partition. Okay, we can call it mount point. df-h, there is nothing as a scripts here, so use mount slash dev centos and scripts, mount it here. Use df-h to verify. You see, after team, now we have scripts. So you can see we were using a whole disk there as an independent partition, and we mounted it here. Now we are using LVM. So one slice of logical volume we are using to access the volume through this scripts mount point. Of course, it will not be available when we reboot the system, so we have to make an entry for this as well. So we can just say echo this thing, mount it here, and this is xfs, use defaults 0 space 0 double greater than sign, so that we don't overwrite the file, we append, we add at the end of the file. Okay, we already have a backup available, no worries. Now we can verify. So for verification we can use diff also, which we used earlier. So you can see now two new lines are there. So if I use df-h, we have not mounted it yet. Oh, we already did. So we unmount it for testing purpose. Wait, we can do one more thing. Just go in here. There is nothing, so we create a temporary file, touch, maybe one code. So whatever code you want, you can write here. So get greater than hello, hello, world dot sh. So one shell script I am writing here, slash bin bash echo hello world. Chmod plus x. Okay, execute permission is there. Now execute it. Hello world. So one script is there now. I use cd to get out of that directory and back to my home directory. Now what I do, unmount it. Scripts df-h, it is not present. I use this scripts, nothing is there, but the disk, the logical volume has our data, right? So now we use mount -a because it will read all the entries from fs tab. Now use df-h again. You see script is there and you can really verify your data percent there. Done. So we have done this exercise successfully. Now another scenario, if we think that we need more space for this volume, we can increase it. We can increase the size of this volume. Okay, because this is just one of these volumes. Okay, so any volume we can use to increase its size. Swap volume is there, we can increase its size also. So for this exercise, I'm going to increase the size of slash where, because I'm going to have data there, so I need it bigger, of a bigger size. So as you can see, it is 3 GB large already. Slash where now vgs. So I have 2 GB of space. I want to use all of that space. So what I do, lv extend, not create. This time we are extending, and what we are extending, slash dev. This is the group name and the volume name where. We can also use this mapper line. Now what is the size you want? So plus 2 GB. Okay, after that we can use -r option to resize the file system, because the extra storage we are going to use is doesn't have the knowledge of the file system. It would be xfs, ext4 or what. So we can use -r here, so it will apply the file system layer automatically, or we can run resize to fs command separately. So we can do both the exercise. So let's do this in 2 steps. First 1 GB with -r option and see what happens. So you see the size was changed from 3 GB to 4 GB, and with the help of -r, logical volume centos were successfully resized. And these statistics you can recall from the formatting command which we use mkfs earlier, right? So we didn't have to call it manually because we used -r option. Now we can verify the size of this volume. So it is slash where, now it is 4 GB. Okay, now what we do the same exercise again. Don't use -r this time. See, only one. Okay, there is not sufficient space. Okay, 256 extents needed, but only 255 are there. So in roundabout round number, so if I use, for example, -l, I can just say that use these 256 extents, but I can do this uh, if I don't know, plus free 100%, I think. No, plus 100% free. So okay, so whatever Space was available, we used it, plus 100% free. Now it is 4 CBLRs. So volume centers were successfully resized, but you don't see these lines, okay, because we have not actually resized the underlying file system type layer. Okay, so we have to use this command resize to fs file system. Resize to fs gets the idea of the underlying file system type ext34xfs from the super block, and it will perform its work automatically. Otherwise we can also use xfs grow file system. This is applicable to xfs only, so use it. Now we can use this line as well. Okay, so data blocks now changed from this to this, you see. Now use df-h slash where it should be 5 GB now. Excellent. Now vgs, we don't have any space left there, 0. But recall, we created 3 disks, so one is used as an independent partition separately to hold the folder team. uh, that team folder is holding this partition. Okay, recall this thing slash team. sdb2, we used it, and we used all the space to extend our logical volume slash where, okay, from 3 to 5 GB lars. SDB3 is still free. We have not used it. You can verify, use PVS, because you don't have to remember everything. That is the job of your computer system. SDA2 is used, SDB2 B2 is used for PV, but SDB3 is not used. Maybe it is used as an independent partition, mount point, etc. You call. So you can use df command here. Simple. Okay, and then grep for SDB3 there is nothing, but SDB2 there is nothing, and for SDB1 there is something. So both the commands df and pv you can use to verify if it is already being used. Of course, if you use lvcreate command for SDB3, and if it is already in use, it will tell you. It won't let you perform the activity. Okay, so don't worry about that. You want to verify, we just use SDB2. Okay, so let's do this. Lvcreate dev SDB2, and let's see what happens. Cannot initialize. Okay, not initialized, so you cannot use it. But if you want, you can try some force actions. So no worries. Now for this we can again make it part of our LVM, or we can use it as a separate partition as we did for STP1. So I think we have covered all the exercises. Okay, so you can now get your hands dirty, do some practice, because it is already almost 39 minutes, 40 minutes or so. So it's very lengthy video this time, but I had to complete all the steps or most of the steps. Now, before I say tata to you, I give you something here. Use df-h to verify the final status of your volumes. Use T, capital T here, to include one more column here, type. So you can see XFS or any other file system you are using. Okay, if you don't use that capital T, then you don't see that column also. Now, so when you use this H, what happens? Without it, you get the size in 1K blocks. So with the help of H, you get it in human readable format. So you don't have to do the translation from the the mathematics from kilobytes to megabytes and CB. The df command does it for you. So use them. Now I think we are done. We are good to say tata to each other. So thank you guys. Bye bye.